So the student asked me this question. If 85.7 milliliters of lead-2 nitrate reacts completely with excess sodium iodide to yield or to produce 0.427 grams of precipitate, what is the molarity of the lead-2 plus ion in the original solution? So first things first, let's go ahead and balance this reaction. And also change this stuff to liters instead of milliliters. It says 0.427 grams. We would normally immediately turn that into moles, but we can't do that because we don't have the reaction yet. So let's go ahead and write this out. We have lead to nitrate reacts with sodium iodide, and that's going to form lead to iodide because it's double displacement reaction, and sodium nitrate. All right, so let's balance the reaction. Over here I have 2 nitrates, so I got to put 2 there. That changed the number of sodiums, so now I have to put a 2 there, and this reaction is now balanced. Okay, we know that it said if 0.0857 milliliters is reacting with excess over here, but we don't know how many moles of this was originally reacting. But in a double displacement reaction, you actually end up assuming 100% yield because the solids are really attracted to each other. So they make sure that if it can happen, it will happen, and they'll make a solid. So let's briefly discuss which is going to be the solid. This is aqueous because we have nitrate. Nitrate, remember the Nas and the nose are always aqueous, so this is aqueous. This one's also aqueous, and if you don't know this, we have to look up solubility rules and make sure you really understand those. Lead-2 iodide is a solid, and here we have Nas and nose together. Those are definitely aqueous. So this is our solid that we're talking about. So when it says 0.427 grams of precipitate, that is what it's discussing. So we've got 0.427 grams of this. Now if you look up or calculate the molar mass of lead, lead-2 iodide, you'll find that it has a molar mass of about 461.01 grams per mole. So I'm going to take 0.427, 0.427 divided by 461.01. And I get an answer of 0.000926 mole. So this is how many moles of lead-2 iodide I made. Well, hey, if I made this much, how many moles did I originally have to have over here? Well, again, because we're assuming 100% yield, we had to have had the same because this is a 1-to-1 ratio. If we had been using this, we would know for every one of those we had 2 of those, or twice the amount. However, it's talking about lead-2 nitrate because this is the liters of lead-2 nitrate, and it asks us the moles of lead-2 in the original solution. So we know that we have this many moles, and we can go through and do the math just to make sure that we're on the same page. And this was of the lead iodide. We know for 1 mole of lead iodide, we had originally 1 mole of lead-2 nitrate. And this will give us lead-2 nitrate mole, 0.000926 mole of lead-2 nitrate. That's not where we're stopping. It asked us for the concentration of the original lead-2. Well, for every lead-2 nitrate, you have 1 mole of lead-2. We could have even continued this on and said, hey, for 1 mole of lead-2 nitrate, we have 1 mole of lead. So essentially we're saying we've got 0.00926 mole of lead-2. And if you remember, concentration is in mole per liter. Well, we knew that we had that many moles, and it came from this many liters, 0.0857 liters. So we take 0.000926 and divide it by 0.0857 liters, then I get an answer of 0.0108 mole per liter. And hopefully that makes some sense. And this would be mole of lead 2+. Have a good day.